Hello everyone. So today in this video we are going to see complex number, addition, subtraction, multiplication, division and everything. So first let's understand what are complex numbers. So complex number is a number that combine a real part and a imaginary part, and we write it in this form: z is equals to a plus bi, where a and b are real numbers and this I is the imaginary unit. So wherever you see I, this is imaginary part, and I square is equals to negative 1. Okay, this you have to remember this value. Like if you put a square root of negative number in your calculator, you get error because this is not a real number. So we need to learn these imaginary numbers. um, let's see how do we simplify them. With the help of questions we will understand them better, right? um, so, like in this question, this negative 2 and negative 4, this is the real part, and this negative 2i and negative I, this is imaginary part. So, we always solve real with real and imaginary part with imaginary. Like here, first we open this parenthesis. So without parenthesis, this is what we have. We just removed it. Now we solve this real part with real part. So negative 2 and negative 4 gives us negative 6. Then negative 2i minus I gives us negative 3i. So 6 is the real part and negative 3i is the imaginary part. That's how we simplify it. Like this one, we do real part with real part. So here we will get negative 1, right? Then imaginary part 4 plus 4 minus 3i, we get I, right? So this is the like general form of complex number, where a is negative 1 and b is also negative 1, right? Okay. uh yeah, in this one again we solve imaginary part together and real part together. So as you can see here, first we open parenthesis, so we write this number as it is this. To open this one, we multiply this negative sign with negative 4, we get positive 4, because negative, if we multiply two negative number we get positive number, right? Then we multiply this negative with this negative, so negative negative will become positive, positive 2i, right? Now we have our real number is 4, so we can just write it as it is. But imaginary number negative 3 and 2, this gives you negative 1, negative 1i, and then this is positive 2i. So 2 minus 1 is 1, so that's how we got 1i plus 4. So which is a complex number because it has I. Any number which has I is complex number. Okay, so for example, if I just write 4i, this is, I can say this is complex number because here the real part is 0, right? I can write it as z is equals to 0 plus 4i, right? So real part is 0 but imaginary part is this. Okay, again in this question, we solve real part with real part. Let's do it here. So this is real part. First of all, we need to open this parenthesis. So negative 4, negative I. To open it, we multiply these two. Negative negative will become positive 2. Then negative negative will become positive 5i, right? Now this basically negative 4 and positive 2. This will become negative 2, right? And negative I plus 5i, this will become uh, 4i, right? 5 minus 1, 4. So this is my like simplified complex number. Now let's see how do we multiply two complex number. It is same as we multiply to real number. Like if we have two parentheses, we multiply this with this, right? So 5 times 3 is 15, then we multiply this with this. 3 times I is 3i, right? Then we multiply this number with this. 5 times 5, 25i. Then we multiply 5i with I. So this gives me 5i square, right? Now, as you can see, these two, they are like terms. Like terms means like same terms. They have same variable. We can say they both have I, so we can add them, right? So 25 plus 3 is 28i. And as I told you, I square is equals to negative 1. So at place of I square, I can plug negative 1. So this will become 15 plus 28i minus 5, right? So 15 minus 5 is 10 plus 28i. So that's my answer, 10 plus 28i. Okay, that's how we solve. Multiply complex number. Okay. Um, so you just need to remember that I square is equals to negative 1. Basically, like the value of I is square root of negative 1. If you square both side, this square root cancel out. Um, this square and square root cancel out, you get negative 1 here, and this is I square. So that's how I square is equals to negative 1. From here we can find I cube. Like if I multiply both side with I will get I cube, and this will become negative I, right? If I multiply both side with I, this is what I am going to get. To find I to the power 4 is I can multiply this expression with I square. So that's how we can do it. So basically, um, now like if we have to multiply this one, to simplify it we can multiply these two. So this will give me negative negative positive answer. So 3 times 2 6 I square, I square. Then we have 4 minus I. So we multiply this with this, right? So this will give me 24 I square. Then we multiply this with second term. So 6, this will become 6I to the power 3, right? So I square is negative 1. So at place of this I square, I can plug negative 1 minus 6. As I told you here, I cube is equivalent to negative I, right? So at place of I cube, I can just plug negative I. So this will become negative 24, this negative negative will become positive 6i, right? So that's my answer. Um, that's how we can solve these type of questions. Now again we can try this one. So how do we do it? Basically, okay, the solution, I thought I wrote it. First we multiply this term with this. So this will become 5 times 1 is 5. Then this will become plus I. Then I times 5 will give me 5. I times I will make I square, because they both are negative, so my answer is positive. Now 5 plus 5 is 10 plus I, and then I square is negative 1, right? So this will become 10 plus I, plus minus is minus 1. 10 minus 1 is 9, 9 plus I is my answer. That's how we solve or multiply complex number. We know complex number has two parts, real and imaginary. This is real part, and the one which has I, that term is imaginary term. So now let's see how we graph complex number. So we graph it same way, but instead of x and y axis, we have real and imaginary axis. Real is this axis, like x axis, imaginary is y axis. So let's say we have 5 minus I. If it's just I, that means the coefficient is 1, right? 5, either I write 5 minus 1I or 5 minus I. They both are same thing. So x is 5. Now if you see 5, 1, 2, 3, 4, 5. This is my 5. Then it's negative 1. So I need to go downward. Negative 1. So this is my point, right? That's how I can graph complex number. Negative 1. So negative 1 is this real number. Then positive 4. So 1, 2, 3, 4. So this point is representing negative 1 plus 4i. This one x is 5. So 1, 2, 3, 4, 5 is this. Then 3i. So 1, 2, 3. This point is representing 5 plus 3i. Now for this, let's say we have to determine complex number. So x is, as you can see, it's towards negative real number. So negative 2, because it's 2, 1, 2 plus 2i, right? Because imaginary one is positive. So this one is negative 5 because it's going downward. So negative 5, uh, one, because it's towards this direction left, so negative 5, 1, 2, 3, 4, and negative 4i because it's downward. For this one, x is negative 2, I mean real part is negative 2, as you can see 1, 2, and imaginary part is 1, 2, 3, 4, plus 4i. With imaginary part we need to put I. Okay, so now let's see how do we find absolute value of complex numbers. Absolute value is like we always get, for example, absolute value of negative 5 is 5. We always get positive value because it is the distance from 0, right? So for example, if we have this complex number 3 plus 2i, so here this is 3 from 0, this is 3, and then this is 2. And imagine absolute value means we find distance from 0. So what is the distance of this point from 0? This, right? That means we got a right triangle like this. So right triangle, we can use Pythagorean theorem, right? If this is 3, this is 2, how can we find this distance? We can do square root of 3 square plus 2 square, right? We know if we have a right triangle, and this is A, this is B, this is C. So according to Pythagorean theorem, we can do C square is equals to A square plus B square, right? And if we square root both side, we get C is equals to square root of A square plus B square, because this square cancel with square root. So in absolute value, basically you need to just square their coefficient and then do square root of that. Like if we have to find absolute value of this complex number, we square negative 9, then we square 5, we add them. So 9 square plus 5 square, 81 plus 25, then we do square root of this, which is 106, and that's how we got our answer. Okay, so like for this one, we square negative 10, negative 10 square plus positive 10 square. This will give me 100 plus 100. And then square root of this. So this is square root of 200. We can factorize it, right? Which is 10 square root 2. That's how we find. Because as I told you, absolute value means distance from 0. Like if this is 10, this is 10, I need to find the distance of this point from 0, which is this. So I can use Pythagorean theorem for this, right? Now again I have to determine absolute value. So I do square root of negative 8 square plus negative 4 square, right? Which is 64 plus 16. Then I do square root of this. This is going to be 6 plus 4 is 10, 6, 7, 8. So square root of 80, right? Now let's see how do we rationalize complex number. Rationalizing means, let's say we have a complex number, like for example when we have like we have, for example, if we have a fraction where we have a square root number in denominator, to remove this from the denominator, what we do, we multiply numerator and denominator with this number, right? Because this is going to, like, now if I multiply these two I get 3 root 5, and these two I get 5, right? Because square root this is going to give me 5, right? Now um, in the same way, if we have a complex number where in the denominator I have like I, this term I term, so I need to rationalize it. How do we rationalize? We multiply numerator and denominator with I. Like here, if I have 1 over 7i, so I multiply numerator and denominator both of them with I. So I times 1 gives me I, and 7i times I gives me 7i square, right? I square is equals to negative 1. So at place of I square we can plug negative 1. Then in numerator we have I, 7 times negative 1 is negative 7, right? So my answer is negative I over 7. Okay, so that's how we do. Now to rationalize this type of number, so here denominator is 5 plus 3i, so I multiply both of them, numerator and denominator, with 5 minus 3i. So whatever is my imaginary part, I will switch the sign. Like it is plus 3i, so I need to do minus 3i. Okay, then I know how to multiply them. If I multiply these two, what I get is, let me just remove this. Okay, so I do 6 times 5, which is 30. Then I do 6 times 3, which is 18i. Similarly here, what I can do, I can use this formula because I know a plus b times a minus b is equal to a square minus b square. So because this is in this form, a plus b and a minus b, right? So 5 square is 25 minus, this is the minus from this formula, b square, b is 3i. So 3i square is 9i square. Now we know I square is negative 1. So at place of I square, I can plug negative 1. So 25 plus 9, I got 34, right? So basically, if you see in this one, I can take 2 common. From 30 minus 18i, if I take 2 common, I will get 15 minus 9i. Now if I divide this 2 with 37, I get 17 here. So my answer is 15 minus 9i over 17, right? Like if I have to rationalize this number, my denominator is plus 3i. So my imaginary part, only the imaginary part sign will, we have to flip only that sign. So this plus 3i will become minus 3i. Now I will multiply numerator and denominator with this term. So basically, first we multiply this term with this, then this with this. The same thing we do for second term, right? And in the denominator, I can just apply that formula, a plus b and a minus b, right? So yeah, let's do this. So first we do this 8 times 4, 8 times 4, negative negative will become positive, which is going to give me 32. Then 8 times 3, this is again going to be positive, there is I, 24i. Then I do 6 times 4, so which is again going to be positive, 24i. Then this is going to be 6 times 3, 18 I square. There are two I, so it's we'll get I square. Here I will use a plus b formula. So this is going to be a square minus b square. A is negative 4, so negative 4 square minus negative, not negative, actually I should just write 3i square. Okay, so this is, now I just add them. So I have 24i 2 times, so this will become 48i, right? So 32 plus 48i minus 18, because at place of I square I'm going to put negative 1, so this will become minus 18. 4 square is 16 minus 3 square is 9. I square will become minus, because I square is negative 1, right? So this is going to be, if I expand it, I will get 9i square. At place of I square, I plug negative 1. So this will become negative negative positive 9, right? Now I tried to solve this. 32 minus 18 in numerator, right? So this 32 minus 18 gives me 14 plus 48i. Let me just erase this part. So I got 14 plus 48i, and in the denominator I have 16 plus 9, which is 25, right? So that's my answer, 14 plus 48i over 25. Now you can see in denominator we don't have imaginary part, it's real part, a real number 25, right? Okay, now let's see if we have quadratic equation with complex number, how do we solve it? Because we know I is equal to square root of negative 1 and I square is equals to negative 1. um, so suppose we have this question, x square is equals to negative 16. So if I square root both side, this is what I'm going to get, right? Square root of negative, and this side I will get plus number plus minus both, because square of positive number, like if I square negative 4 or if I square positive 4, in both case I'm going to get 16. That's why we write plus and minus both. Now this square root and this square cancel out. So this is what I get. Can I write this square root of negative 16 as square root of positive 16 times square root of negative 1, right? I can split it into these two terms, right? Now I know this is I, right? Square root of negative 1 is I. So at place of this I can put I, and square root of 16 is 4, right? So I get x is equals to plus minus 4i. So which I can like write as either I can write as x plus 4y. I mean, there are two roots, x is equals to 4i and x is equals to negative 4i, right? um, in this question, now let's take another one. For example, we have x plus 4i and x minus 4i is equals to 0. So what we can do it is like from here, if I just equate it, I take 4i to other side, I will get negative 4i, and if I take this negative 4i to other side of equal sign, I will get positive 4i, right? um, but this is only when we get under square root, we if we have a negative number, we put that as I, and that's my imaginary number, right? Like if I have this x square is equals to, if I take to other side of equal sign, I will get negative 9, right? If I take this side, or if I subtract 9 both side, this will cancel out, and this is what I get, x square is equals to negative 9, right? Now I do square root both side, so this will cancel out, and this side I will get plus minus square root of negative 9. Now what I can do, I can write square like positive 9 and square root of negative 1, right? I can put it like this. And square root of 9 is 3 plus minus 3. And this is nothing but I. So I can plug I here. So I got these two roots, plus 3i and minus 3i, right? That's how we can solve it. Then we have this one. So here we need to take common. Um, we can take 2x common from both terms, right? So here we get x square plus 16. What you can do is 2x is equals to 0, and other way is you take because you have x square plus 16, so you take 16 other side, it becomes negative 16, right? Then you do square root both side, you can write negative 16 as positive 16, and then square root of negative 1, which is I, and square root of 16 is 4, so you got x is equals to plus minus 4i, right? In this one again you can take 5 common, 5x to the power 2 common from these two terms, right? Because this is the factor, so you get x to the power 2 plus 9 inside, this is remaining. So 5x square is equals to 0. That means from here if you divide both side with 5, you get x is equals to 0. For this you take 9 other side, so you get x square is equals to negative 9. Then you do square root both side, you get x is equals to plus minus square root of 9 and square root of negative 1, which is plus minus square root of 9 is 3 and square root of negative 1 is I. So that's how you got, right? So if you can take common, that's how you have to do. But like if you see this quadratic equation and you plug it in calculator, you will get error. Why? Whenever like you have this type of quadratic equation, you can find determinant, which is b square minus 4ac. If b square minus 4ac is less than 0, that means roots are going to be complex. Okay, so like in this case, b square 10 square is 100, minus 4 times a is 1, a is x square coefficient, and c is 30, right? So 100 minus 120 is going to give you negative 20. So b square minus 4ac is negative, less than 0. So you have, there won't be any real solution. The solutions are going to be complex. So in that case, always use quadratic formula. This is quadratic formula. This, right? Where a is coefficient of x square, b is coefficient of x, and c is constant. So you can just plug these values and find it. Like here, if we plug all these values, negative 10, b negative 10, like in formula we plug b square, then minus 4ac over 2a. So this is, we already did this, we got negative 20 b square minus 4ac. Now negative 20 can be written as square root of 20 and square root of negative 1, right? So negative 1, this we write it as I, right? And square root of 20 we write it as, because if you like factor it, 20 you divide it with 2 you get 10. Again 10 is divisible with 2, so we get 5. We divide 5 with 5, we get 1. So this value, if you make a pair of same number, you can take them out of square root, so you get 2 and square root of 5, right? Now you can divide both of these terms with 2 and write them separately. Now you cancel 2 with 2, and this 10 divided by 2, 5. That's your answer. So you can see the solution is complex because there is imaginary part as well as real part, right? So that's how we solve. Um, like in again this question, if you find b square minus 4ac, you will get negative 23. So if b square minus 4ac, this value is negative, that means this quadratic equation is going to have complex solutions, no real solution. So you use this quadratic formula to find roots, plug a b c all these values, then you will get negative value inside square root. You split it into a positive square root and then a square root of negative 1, which is equals to I. At place of this just plug I, everything is same. Okay, and this one again you use this formula, because b square minus 4ac is coming negative 44. That means if b square minus 4ac is negative less than 0, the roots are going to be complex. So you split it into negative 1 square root and positive this, and which this is equal to I, right? That's how we factorize um, quadratic equation using quadratic formula. Now this says determine equation if the zeros are given. See, if zeros are given, how do we determine equation? In this case, we have x negative 2, negative 2i, and negative 3i. What we can do is, uh, basically, we can write it as x minus minus, because this is like, basically I have these functions. Okay, this is a separate question. Yeah, so I can write it as x minus minus 2 minus 2i, and then I can write, because there are two solution, plus minus both of them are possible, so we write minus and then here plus, right? Similarly for this, there are like if 3i is the solution, its conjugate is also going to be solution, so we write positive 3i and negative 3i. For this one, first we wrote positive 2 and positive 2i, then we just change the sign, positive 2i and then negative 2i. Similarly, if 3i is solution, negative 3i. Now if I multiply all these terms, I get my equation. Okay. Okay, that was it for today. Thank you.